So describe Alright, so let's go back to the flow chart that you would have given, alright? And then you have to remember some basic methods like filtration and allow it to crystallize, right? You know, like the filter paper, you have to know how to describe those stuff when you're doing this in the exam, alright? Now, how would we prepare a sample of zinc nitrate? Starting with the carbonate.
Would it be like that in process?
Precipitation.
Yes, sir.
Alright, what's the first question?
First question is it a soluble or insoluble solid?
Yes, and if it's yes,
If it's yes, it will be dynamic precipitation.
yes. But remember that we also have to. Alright, we can use that. Any precipitation, alright? Alright, what would we use as the starting material then? Because the problem what I'm having is that it's because they give us something to start with that throws off. Because zinc carbonate is insoluble, so we can use any precipitation. You get the reasoning behind here?
Yes, sir.
Good. Because if they didn't give the zinc carbonate, it would have been any precipitation, in all fairness to you. This should have been any precipitation. Because the first question is the salt soluble or insoluble? If it's insoluble, we should have used any precipitation. But because they give us that we should start with the carbonate, we can't use any precipitation. We have to use the carbonate plus the acid. You following? So that's how the exam will test use of knowledge. Because a student that don't have much knowledge will say, oh, it has to be any precipitation because it's insoluble. Alright? Alright, first is the salt soluble. It's a soluble salt. So we have to ask the next question, is it a potassium, sodium, ammonium salt? It's a no, so we go to the align the no. So that means it cannot be titration, it cannot be ionic precipitation based on this salt, alright? Is it an anhydrous chloride? No, so it cannot be direct combination. So it has to be the reaction between the carbonate plus the acid, alright? So A is gonna be zinc carbonate, solid. We have to then react this with the acid which contains the nitrate, so it's going to be HNO3, AQ. Alright, remember that this is going to produce zinc nitrate, AQ, plus CO2 gas, plus H2O liquid. Following? So this method is method 4, in which it's insoluble carbonate plus the acid. Alright? Now, I can erase this, we have this already. Alright? So how we are going to do this now is that we have to have a container first. Right? This is with nitric acid. Right? And then we are going to add excess zinc carbonate, solid. Right? After this reaction occurs, then we are going to filter off the excess solid. Right? Because we want the reaction to finish. So we want when the reaction stops, we want all the protons to be used up from the solution, leaving just the zinc carbonate as excess in the bottom here. So this is going to be excess zinc carbonate. Our leftover solid, right? Now we're going to filter it, and then so the excess zinc carbonate is going to be here, right? And in here, now the solution that we have here is going to be zinc nitrate, AQ, right? And then we leave this solution to evaporate, and then we will form the water of crystallization. We form crystals from evaporation. So we call that method crystallization, alright? Alright, now, barium sulfate. Next salt is barium sulfate. Is it a soluble or insoluble salt?
Soluble.
What?
Sulfate and boron.
And the barium.
Boron.
Soluble or insoluble?
Insoluble.
Good. For all sulfates are soluble except barium and what? Lead?
And lead.
Good. Alright? So this is the insoluble salt. Which method do we use? Ionic precipitation, right? So, alright, so we have to choose two reactants. It must be Ba plus SO4. No, so remember that both of these have to be AQ, alright? Because we are going to need the barium sulfate solid plus something, alright? So it simply means that we have to choose one of the reactants. Both reactants have to be soluble. When we add them together, it will form the insoluble. This is ionic precipitation. So which barium ionic compound we know it's soluble? Barium nitrate, right? Because all nitrates are soluble, no exception. Right? What do we use for sulfate?
So we can use potassium sulfate.
Good, potassium sulfate. Right? So we'll form barium sulfate solid plus potassium nitrate. Aqueous. Alright? Then after we form this, what do we need to do next to get the barium sulfate salt?
And the equation said?
No, the method of preparing, we need to filter it. Alright? So this is how it's gonna go. So one container will have barium nitrate. Next container, I'm gonna pour in. We have potassium sulfate. So we're gonna pour this over in this one, right? And then what we're gonna get here is this is gonna be barium precipitate out of solution, right? And we're gonna filter it. Now then we're gonna filter it again, right? So this we put in a filter. But now this is the barium sulfate that we want. So it would be one in the filter paper. Because filter paper will allow aqueous ions to pass through but not solid ions, compound. Alright? Good, so that's the method. Alright, potassium sulfate, starting with potassium hydroxide. So is it a soluble? Soluble. And is it a potassium, ammonium, or sodium salt? Yes. So we use titration.
Yeah, hold on, so repeat that. Is it?
The flow chart is the salt soluble or insoluble? It's soluble. So if it is soluble, we have to check whether it is a sodium, potassium, or ammonium salt, which is, it is yes, and that's we're going to use titration, right? So the titration is going to be between potassium hydroxide and sulfuric acid. So we put them in an equal mole ratio to form the potassium sulfate, and then we will just leave it to crystallize. Because remember that it's going to form the potassium sulfate, the sulfuric acid and the potassium hydroxide is going to form potassium sulfate plus water. So we can just leave it to precipitate if we have it in the right mole ratio. Good? So C is titration. The titration. So we'll do the titration. This is like the potassium hydroxide. So remember that it has to be 2 to 1 mole ratio. 2 to 1. And what we're gonna form here is K2SO4 plus H2O. Right, so after we finish this titration 1 to 1 mole ratio, we can just leave it to crystallize.